This is going to be a flip video on moles and some basic particle conversion. So in chemistry we use the word mole, and all a mole is it's just a number. That is it. It is a word associated with a number. Like, for example, do you know of any words that you associate with numbers? Hopefully you've said yes. Dozen, baker's dozen, maybe pair, right? So if we take a look at these more common examples, you know that the word dozen means 12. You know that baker's dozen means 13, and the word pair means 2. These are all words that you associate with numbers. That's exactly what we're going to do with mole. The mole is just a number we use in chemistry, and it's a number that we use to count things with in chemistry. So we don't really use dozen, baker's dozen, or pair in chemistry. These tend to sometimes be used more with cooking or with clothing. Mole is what's used for chemistry. So what is a mole? Well, if a dozen is 12, a mole is a huge number. A mole is 602 hexatrillion. So let's take a look at that. A mole, also known as Avogadro's number, a mole is equal to 602 hexatrillion. Well, that's enormous. So we write it in scientific notation, 6.02 times 10 to the 23rd. So a mole is a huge, huge, huge number. And this number is called Avogadro's number, named after the scientist who proposed this idea, Avogadro's number. So 1 mole is equal to 6.02 times 10 to the 23rd of whatever you're talking about, right? So just like we say maybe we have a dozen marbles, you know that you would say that there are 12 marbles. Okay, well, what if I said I had a mole of marbles? How many marbles is that? Well, hopefully you said 1 mole of marbles is 6.02 times 10 to the 23rd marbles, or 602 hexatrillion marbles. So what if I said that I had a dozen pens? Well, you would have said I had 12 pens. Well, what if I have a mole of pens? Same thing, 6.02 times 10 to the 23rd pens. So hopefully you could see the similarity in what a mole stands for. What if I had 1 mole of U? How much of U would I have? Well, if I had 1 mole of U, I'd have 6.02 times 10 to the 23rd U's. Okay, see, you can really do anything you want. Except in chemistry, we don't really deal with marbles and pens and U necessarily. So what is it that we're counting? Well, we're counting particles. What are some popular particles that you've seen in chemistry before? Well, let's take a look. Don't these look familiar? In chemistry, we don't deal with marbles, we deal with molecules. We don't deal with pens or U, instead we deal with atoms. And formula units. Formula units is another way of saying ionic compounds. So an example of a molecule would be something like, maybe you want to know how many moles of water you have. An example of atoms would be, maybe you want to know how many moles of carbon you have. And formula units would be, maybe you want to know how much NaCl. Those would be all examples. Okay, these are all called particles. So, kind of put it for you like this. And this would be a great thing to put in your notebook right now. And maybe make it 1 whole page in your notebook, nice and big like I've done here, to take up the entire page. Put a nice box around it, make this stand out. These are, if you notice again, these are the particles, molecules, atoms, and formula units. And all I've done is I've taken these popular particles and I've written out what you know, and that is 1 mole of water is an example, is equal to 6.02 times 10 to the 23rd molecules of water, because water is a molecule. 1 mole of calcium is 6.02 times 10 to the 23rd atoms of calcium. Again, calcium is an atom, that's why I picked calcium. 1 mole of NaCl is 6.02 times 10 to the 23rd formula units of NaCl, and I called it formula units because this is an ionic compound. Again, 1 mole of anything is equal to the same number. It's like saying 1 dozen is equal to 12. 1 dozen is equal to 12. 1 dozen is equal to 12. Okay? Great. Now, the nice thing is, these are our main particles. We aren't going to be talking really about much of any other type of particle. So, we're going to have to now do particle conversions, meaning what if I, instead of asking you about 1 mole, I ask you, well, what if I had 2 moles of water? How many molecules would that be? Hopefully you'd say twice as many. And what if I said I have 3 moles of water? How many molecules of water would that be? And hopefully you would say 3 times as many. Okay? Those are easy to do, except we have to use our dimensional analysis setup. Yes, it's back. It's the same setup we've learned at the beginning of the year. So how do we do that, and what would a problem look like? Well, first of all, let's remember that all of those conversions can be written as conversion factors. So let's take a look at this one first. As you saw on the sheet and you have in your notes, 1 mole is equal to 6.02 times 10 to the 23rd atoms of whatever you're talking about, whichever element you want to talk about. In my previous example, I was talking about calcium, and I mentioned carbon. So this can be written as a conversion factor seen here. Or we could flip it like this. Okay, great. What was the other one we talked about? Remember, the other particle was molecules. Same thing here. This is the same thing. 1 mole is equal to 6.02 times 10 to the 23rd molecules. In my last example, I used water. So you can write it like this or like this as a conversion factor. And the last particle I talked about was formula units. So let's take a look. 1 mole is equal to 6.02 times 10 to the 23rd formula units. You can write it as a conversion factor like this or like this. Hopefully you realize these are all the same thing. The only difference is we're talking about atoms, molecules, formula units. It's like saying marbles, pens, and U's. Okay, so it doesn't matter what you're talking about. It's the same conversion. It's just the back end detail gives us a little bit more information. Okay, these are the chemistry ones. All right, so let's look at an example problem. Here we go. How many molecules of CO2 are there in 5.0 moles of CO2? Okay, so if you notice in this problem, we're given 5.0 moles. And we want to take moles and we want to go to molecules. How many molecules, right? So we're going from moles to molecules. Well, I know that a mole of something is 6.02 times 10 to the 23rd of whatever you have. We have molecules that we want to go to. So 1 mole is equal to 6.02 times 10 to the 23rd molecules, right? Let's bring up that molecule one really quickly. 1 mole of whatever you have is 6.02 times 10 to the 23rd molecules. All right, that's easy enough. So let's begin. We start with our given. You always write your given here first. Don't forget to label it. Moles of CO2. Now be careful. Mole is abbreviation for mole. MOL is not the abbreviation for molecules. There is no abbreviation for molecules. Be careful. Okay? Now I'm going to put in my conversion factor. That's what this is here. It's something that helps convert me from one unit to the next. I'm trying to go from moles to molecules. Oops. Let's fix that up. I made that mistake right there. Moles to molecules. So this is a conversion factor, and that is 1 mole of anything is equal to 6.02 times 10 to the 23rd of that thing. Well, 1 mole of CO2 is equal to 6.02 times 10 to the 23rd molecules. That's how many molecules are in a mole of CO2. Just to remind you, I got that from here. 1 mole is equal to 6.02 times 10 to the 23rd molecules of CO2. Okay? When I'm done setting it up, I'll then multiply. Do 5 times this fraction. So 5 times 6.02 times 10 to the 23rd divided by the 1 in my calculator. And I get a final answer. Well, let's take a look. Moles of CO2 and moles of CO2 cancel out. Top and bottom units should cancel out. That's how you know how to correctly flip it. So go ahead and plug this in your calculator, and let's see if you get the right answer. Now, This is a little tricky to plug in your calculator, so I'd like to kind of remind you about that. To put scientific notation in your calculator, let's go ahead and write down some steps. And this is a reminder, maybe you can always remember it. You want to punch in 6.02. Now, when it gets time for the times 10, you don't want to put in times 10. Instead, you want to hit the little circular button that says EE. So there should be a button on your calculator that says EE. When you hit that EE, you're telling the calculator times 10, meaning scientific notation. But don't type in times 10. So you want to hit 6.02, the EE button, and then just the number 23. That's how you put that in your calculator, 6.02 times 10 to the 23. Okay? Good. So now that you put it in, hopefully you've solved and you have an answer. We never look here for sig figs. Instead, look at your given for sig figs. Please write that down. All right. Now, there's 2 sig figs here. Why? The decimal here makes all trailing zeros significant. So 2 sig figs. So your final answer should have 2 sig figs. And the unit should say molecules of CO2. Okay, I'm going to leave that up to you to solve for that. Next. How about this question? How many atoms of carbon are there in 2.0 moles of carbon? If you notice here, I've boxed in the given. It's the number that I'm given. And I'm trying to get to atoms. So I've got moles and I'm trying to go to atoms. Well, I know that 1 mole is equal to 6.02 times 10 to the 23rd atoms. So they want to know what 2 moles is. So it's twice as many. But I have to set it up using my conversions, right? You will not get credit if you do it in another way. So let's take a look. We're talking about atoms. Let me bring back my atoms. And I remember 1 mole is equal to 6.02 times 10 to the 23rd atoms of whatever you're talking about. In this instance, we're talking about carbon. Okay? So I start off with my 2 moles of carbon. Don't forget to label it. You have to make sure you label which atom you're talking about. And then I put moles of carbon on the bottom. Right? There's your first step if you're not sure, because these two should cancel out like seen here. 1 mole of carbon is equal to, well, 1 mole is equal to 6.02 times 10 to the 23rd atoms. So 6.02 times 10 to the 23rd atoms of what? Carbon. Do not forget that. You'll get points taken off. Okay, there are many different atoms. This one happens to be about carbon. Then in your calculator, you're going to do 2.0 times 6.02, EE button, 23, right? Don't forget. Divided by 1. When you do sig figs, look here for the sig figs. Do not look here for sig figs. Please write that in your notes. 2 sig figs, because a decimal in a number makes the trailing zero significant, so your answer should have 2 sig figs. Please do that now and put it in your notes. Your final answer's unit should say atoms of carbon, atoms of carbon. Okay? Good? Well, that's it. We are going to be doing practice problems in class. Feel free to watch this video over again. Make sure you've written down everything you need.